Network consists of three components: a DevPAC unit connected to a laptop, a master of the network, and the slaves of the network. The DevPAC unit will contain all the MAC addresses for all the nodes, and it will pick one and send to this MAC address a scan request. A node which receives a scan request becomes a master, and it will start listening to all the advertisements in the network. The slaves of the network will simply advertise themselves every now and then. The master will receive the RSI values from those advertisements. It will make the average of the RSI values and send it to the DevPAC unit. Once the DevPAC unit receives those RSI values, it can claim the master role and then send a new scan request to a different node. And thus it can be done for all the 20 nodes in the network. The experiment was performed successfully on the 4 nodes. However, once we tried to do it on the 20 nodes, we encountered an issue with the nodes failing during the test. And we couldn't see this until the end of the experiment. And the problem with the nodes was that they were failing because the battery was depleted on them. And since we didn't have much time to investigate the issue, we decided to replace the DevPAC unit with a phone and an application which can scan for the Bluetooth devices. It would change the fact that we would have to pick manually the devices which should become masters in the network. However, those masters would send their RSI values to the phone, and the phone had an option to extract the values into an Excel sheet. And from this Excel sheet, we manually could see if we should replace a battery on a network somewhere or not. We have mainly three scenarios: a car without the people, a car started motor running without the people, and also the car with motor off but with the 3 people inside the car. And the measurements were as follows. So the car without the people inside had decent RSI values varying from 40 dB till 90, depending on the areas. For example, the areas of the seating had the best RSI values of the seating. However, they got worse for the engine, and the engine parts were only good within locally. However, they were pretty much worse for the rest of the car. And measurements done without the people but with the motor running were not slightly changed from the first experiment, um, and also the same holds for the engine parts and for the other parts of the car. However, the measurements with the 3 people inside the car have quite some changes from the without the people. The effects were that some nodes were not able to detect each other. For example, the nodes on the top of the car and the bottom were not able to detect, since the power was much less than the sensitivity of the node themselves. And in order to define that, we used phone measurements to actually define what actual power it is, and it turns out to be 102 for the top and 104 for the bottom of the car, and that was pretty much explanatory, since the signal would have to traverse through the car in order to reach the other node. The path loss exponent was calculated based on those measurements, and depending on the areas, it was in some cases negative, which would be not what we expected it to be, since it would have to be a positive number rather than a negative. So we're not sure if the formula which we used were accurate enough to be used as an exponent calculation. However, the RSI values could be used to define which areas are better to communicate. For example, how well it is to place communication and a wireless node in the engine bay in order to communicate it, for example, with the nodes on the wheels for brakes, for example, or how well the media can work on the seating area with the driver place or the trunk part, depending where the nodes are. We could say that the RSI values measured in the car can be used in order to define how well the connectivity between the wireless node can be, depending on the areas within the car. For example, how the engine parts can communicate with the chassis or for the seating, and how the media could be set up in the seating area. However, the exponent calculation itself is prone to be not so reliable, since the negative values which we got are not realistic ones. And this can be explained by the D0 which we have chosen, and also the additional noise or multipath fading which we didn't take into account into our equation when we calculate the path loss exponent.